Hi, kids. Hi, kids. Hey, we're gonna do a problem here to fill a child's inflatable pool. You need a hose with a diameter of. You use a hose with a diameter of 2.8 centimeters. Water flows from the hose with a speed of 1.1 meter per second. How long will it take to fill a 2-meter diameter pool to a depth of 26 centimeters? Now, being the amazing student that you are, you're going to pause this video and you're going to try the problem by yourself. Okay, so I'll wait for you. Oh, yeah, you did try it, right? Okay. But now I'm going to work through the problem and make sure that you guys are good and you understand. See, I got my handy dandy calculator. We're all good. What do we do first in physics always? Well, we draw a picture that represents the problem. So let's draw a picture that represents the problem. All right, so I have a 2-meter diameter pool. 2 meters. Oh, that means the radius is going to be 1 meter. Okay, very good. And then coming into the pool, I have a hose, okay, that has a diameter of 2.8 centimeters, which means it's going to have a radius of 1.4 centimeters. Very good, yeah. And we're going to have to be careful with units because meters, centimeters. And then we want to figure out how long it takes to fill it to a depth of 26 centimeters, okay? All right, so hopefully you're smart enough to go, oh, okay, so I got my picture. I need to label my important points in the picture. So what are my important points going to be? It's going to be down here for the main pool. So I'll call that point 2 because that's the end. And then up here inside my hose. Okay, so my hose is going to be here. That's there. Well, what do I know? I know that the volume flow rate has to be the same. Because whatever volume comes in has to, be over here. And so then I need to figure out that volume flow rate. Now, if you want to use the equation of continuity, which this is really the equation of continuity, that's A1 times V1 equals A2 times V2. Now, if you're not sure how I went from here to here, watch the last video about that, and it's an amazing video. It's so good, and that will explain it. But if you take a look, so if I do area of this part, well, area of this part is going to be pi times 0.014 squared. The speed there is 1.1, and that would equal, so that's the area of the hose, pi times 1 squared, hopefully that makes sense, times, well, this is what I'm looking for, so I need to know my speed over here. So if I do some math, I'm going to make my pi's go away, because, I like pi, but it goes away. And then if I divide, and I multiply and divide by 1, so let's do it, 0.014 squared times 1.1 equals, and my speed is going to equal 0.00021, like 22 meters per second. Okay, 2156, whatever, meters per second. And you might be like, geez, that's a really small number. Well, have you ever tried to fill up an inflatable pool like this? It takes a long time. So this is what this is talking about. This is like the rate the water is going to be going up. Well, the rate the water is going to be going up is not going to be very fast. But I'm not done yet. I want to fill it to a depth of 26 meters. So if I know the speed and I know the distance, then really all I have to use is this amazing equation, V equals d over t, and then I can solve for stuff. So if you take a look, I know this is 0.00022. My depth is 0.26, and I gotta solve for my time. So then my time is going to be, I'm not gonna use this number, I'm gonna use what my calculator says, But if I go 0.26 divided by the answer, then I get 1,000. It's essentially that many seconds. So then if you figure out, if you divide by 60, it would take about 20.1 minutes to fill up your pool. So there you go. Picture, equation, plug it in, boom. Physics is easy. Bye, kids.